Hi, I'm Steve. You can call me Steve. A while ago, I talked about how fats aren't scary, but I didn't have time to get into much detail about the different types of fats and promised I'd get around to it later. That later is now. In the previous video, I talked about how fats are both high-density fuel and also building materials for your cells. What I didn't talk about is what they look like. Well, they look like this. They've got this water-loving end here and this long, floppy, water-hating, non-polar tail. I talked about polarity during the soap video, if you want to go get a refresher. Chemists call these molecules fatty acids because this end is fatty and this end is acidic. Biologists and biochemists call them lipids, which is simply the Greek word for fat. There are a bunch of different types of fats. You've probably heard of saturated and unsaturated fats, as well as a bewildering array of other ones. Those terms refer to the chemistry, and the differences are found in this tail of carbon atoms. Let's start with saturated fats. Every carbon in this chain has two hydrogen atoms on it, represented by these spiky bits. Right here. This is as much hydrogen as the carbons can possibly hold, which is why we call it saturated. If something, say, a sponge, is saturated with water, it means it's absorbed as much water as it possibly can. Unsaturated fats look like this. You can see there's a double bond between these two carbons, and each one only has a single spiky bit representing a hydrogen. This molecule is not holding as much hydrogen as it possibly can, so it's unsaturated. There's only one double bond in this chain, so it's monounsaturated, mono meaning one, rail meaning rail. If there's more than one double bond, it's polyunsaturated, poly meaning many, rail meaning rail. All of these chemical names sound like gibberish, but once you learn to translate them, they're just describing the structure of the chemical. I'm saying chemical, but all of these molecules are found naturally in plants and animals. Chemicals don't have to come from a lab or a chemical plant. You may have heard of omega-3 fatty acids. Now we're describing where in this chain one of the double bonds lives, although it's a pretty vague description. Omega is the last letter of the Greek alphabet, so here it refers to the last carbon in the chain. In the name omega-3, the omega is separated from the 3 by a dash, but it's more helpful to think of it as a minus sign, because it's referring to a double bond that starts 1, 2, 3 carbons from the end of the chain. Omega minus 3. It says absolutely nothing about where the other double bond lives, because it's not describing a single molecule. Rather, it refers to a collection of fatty acids of varying chain length that have this 3 from the end double bond in common. There are also omega-6 polyunsaturated fatty acids and omega-3 and omega-9 monounsaturated fatty acids, and they all play different roles in your body. The last thing I want to talk about is trans fat. If you look at this double bond, the carbons that continue the chain are on different sides. This one's on the top, this one's on the bottom. Because they're across from each other, we call this trans, which is Latin for across. Incidentally, Transylvania is Latin for across the forest. Transylvania. If I take this carbon chain and I put it here, now both of them are on the same side, and we call it cis, because both of them are on cis side. I am so sorry for that, but now you'll never forget it. Unsaturated fatty acids are in the cis arrangement when they're produced in animals or plants, and become trans once they're partially hydrogenated. When one of the double bonds in a polyunsaturated chain has hydrogen added to it to become a single bond, the other double bond can't switch from cis to trans. Why this is so is the subject of yet another video. Another important lipid is cholesterol, but since it doesn't look like this, I'm not going to talk about it. So which of these are good for you and which are bad? Again, that's a topic for another video. In general, trans fats are bad, cis fats are okay in moderate amounts, and cis unsaturated are essential for your health. What it is about the trans configuration of the double bond that makes it bad is not well understood at this point, but it is certain that it's bad for you. That's fat. It's a variety of different molecules, some of which are bad for you, some of which you cannot live without. Like everything you eat, moderation is the key. Don't cut it out of your diet completely, but do make sure you're getting the correct type and don't overindulge. Thanks for watching. I've been Steve.